Hello everyone. Today I am going to take a question on fluid mechanics, that is from fluid statics. So here the question says a U-tube in which the cross-section area of the limb on the left is one third of the limb on the right contains mercury. So the condition given over here is area on the left limb is one third of the limb on the area of the right. So contains mercury. So this black color thing is the mercury. So the density of mercury is given as 13.6 gram per cc. The level of mercury in the left limb extends to a distance of 30 centimeters from the upper end. So this is very important. 30 centimeters from the upper end of the tube. So from here, so this is the 30 centimeters from the upper end. So till from here only we are having the liquid. What will be the rise in the level of mercury in the right limb if the left limb is filled to the top with the water? Now the question says that what happens if you fill water on the left limb so that the right limb liquid will rises up. So now if you fill this left limb with water, so what happens? So initially till here we are having the mercury. Now once you fill the water here, due to the pressure, there will be some decrement in this column length, and here on the other side there will be the increment in the column length. Okay. Now here you can see this entire length is now of water. Okay. Now here this length is already given as 30 centimeters, and from this initial levels the decrement here is, I am taking it as y. Okay. And from initial levels on the right hand limb till the final level it is, I am taking it as x. Because now the distance from here to here and here to here is what? Same, which is equals to y. And now as per the Pascal's law, we know that on a horizontal level in a non-accelerating fluid, the pressure is same in the horizontal level because this is a fluid statics problem. So we are going to deal with non-accelerating this thing. Okay. Now P1 and P2 are the levels where the pressures are same. Now if you observe over here, now this is the P0 atmospheric pressure on the left limb, and this is the P0 on the atmospheric pressure on the right limb. Now if you take as per Pascal's law, pressure P1 is equals to P2. Here we can write P1 equals to P0 plus rho GH, which is also equals to P0 plus rho into G into H. So we can directly cancel out the atmospheric pressure and also acceleration due to gravity on the both hand sides. So here we will get rho H, this is also equals to rho H. Now if you see this rho H and this rho H are not same because here the liquids are different. Now the density over here is the density which we have to take at this level, pressure P1 level. The entire this area 30 plus y area is now of filled with water. So we have to consider here density of water, and this total 30 plus y is the nothing but height of the water. Similarly on the right limb, if you observe over here, so this is the density of the mercury as well as this x plus y, and this is the x plus y, which is the height till the pressure at a point P2. So we have to consider this as height of the mercury. Okay. Now we don't know this HW and HHG, but we can directly get it from this diagram. Now if you observe over here, this will become rho W, and height of the water is nothing but 30 plus y centimeters, which is equals to 30 plus y, and density of the mercury is nothing but density of the mercury, and the height of the mercury over here is how much? X plus y. So we can take it as x plus y. Now if you see this equation, there are two unknowns. One is x, other one is y. Now in order to get x and y, we can use the condition which was given in the question. AL equals to 1/3 of AR. So I can write that as a volume constant assumption. So we can take that AL into H. What is the left limb height here from initial level? From initial level, the decrement over here is how much? The decrement over here is y. So you can take AL into y. And on the right limb, area into right limb. And what is the increment from the on the right limb from initial level to final level? The increment is x. Okay. Now from this equation, I can write AR equals to 3 times of AL. So I will substitute as it is in this equation. In place of AR, I will substitute 3AL. So okay. AL into y equals to 3 times of AL into x. So AL can be cancelled out directly. So y equals to how much now? 3x. Now we got one more equation. So using this equation and this equation, there are two equations now. To find out two unknowns we have now two equations. Now in place of x I will directly substitute, in place of y I will directly substitute 3x, or in place of x you can directly substitute y by 3. So now what I will do is I will in place of y I will substitute 3x. So we know that density of water. So density of water is nothing but how much? 1 gram per cc, already we know it. So density of water is 1 gram per cc, and density of mercury is given already 13.6 gram per cc. So 1 into 30 plus, so in place of y we need to take 3x, and this is equals to density of mercury is how much? 13.6 and x plus 3x. Okay, now this will become 30 plus 3x, which is equals to 13.6 into 4x. Okay, now what you have to do is you have to multiply these two things. Now 4 6 are 24, 4 3 are 12, 4 1 are 4, 5, 54.4x. 30 plus 3x equal to 54.4x, and 30 equals to 54.4x minus 3x, which is equals to 51.4x. So 30 equal to 51.4x and x equal to 30 by 51.4, and if you calculate this you get 0.58. Okay, now what is the rise in the level of the liquid on the right limb? The rise in the level of liquid on the right limb is 0.58 centimeters. So this is your answer. And by chance in the question if they ask how much level is decremented or in the left limb, you can directly write y equals to 3 times of 0.58, which is equals to 1.74 centimeters. So this is the answer. Hope you enjoyed it. Thank you so much.